everyone, in today's video, I'm going to do a tutorial on how to use Matplotlib's Python library for data visualization. In this video, I'll show you how to use Matplotlib to create simple visualizations like line charts, bar charts, scatter plots, and box plots. And make sure you watch the video all the way to the end for some bonus tips. So before we jump into our Jupyter notebook, let's just go over some prerequisite knowledge, mainly what dataset we're using. So we are using a retail sales dataset. It contains sales information for the years 2010 to 2012. And here you can kind of see a sample layout of what the dataset contains. So you can see we have the store, the size of the store, the type of the store, and then we have the weekly sales by the department of the store. We also have some macro factors here like temperature, fuel price, consumer price index, and the unemployment rate, and whether or not that week contained a holiday. So now that we know more about our data set, let's jump over to our Jupyter notebook and get started with plotting. All right, so here we are in our Jupyter notebook, and the first thing we need to do is our import statements, and we are going to need to use pandas to manipulate the data set. So we will import pandas as PD, and now we'll import matplotlib. So the import statement for that is just import matplotlib.pyplot as PLT. Now the next thing we'll do is read in our dataset, and it's actually split up into 3 different CSV files, and you can find this dataset on Kaggle. I'll link it in the description of this video. So the first dataset is called the sales dataset, and this is the file that actually has the weekly sales for each of the stores. So we'll just do a read CSV and read in that data set. And we'll read in the other 2 as well. And those 2 are the stores data set, and then finally the features data set. Let's take a look at each of those 3 tables individually, just so you can kind of see what they look like. So here we see sales data set has store and department, and then it has the weekly sales. Stores has just the store, the type, and the size. And finally, you'll see on the features data set, we have all that macro information. So here that is. So what we want to do is actually join these 3 data frames together so that it's easier to work with when we're visualizing the data. So we'll need to join 2 of them together, and then we'll join in the 3rd one. So we'll call this sales stores data set because it's going to be the sales data set and the stores data set merged together. We're going to use pd.merge for that, give it our sales data set, give it our stores data set, and we're going to join it on store. And now once we have those joined together, we'll join this to that features data set as well. So we'll call that complete data set just because that's our completely joined data set. We'll use pd.merge again. We'll give it sales stores data set this time. So those are those 2 tables joined together. And we'll join that to the features data set. Now this time we want to actually join this on 2 columns. We want to join it on the store and the date. That way we get the temperature and the fuel price and all of those things in the correct week as well. So here we'll join it on store and we'll join it on date. And we can take a quick look at that data set. All right, so here you can see that we have all of the columns from all 3 of the data sets. And you can see here we have a is holiday X and a is holiday Y. And that's just because this column is holiday is there in the features data set and it's there in the sales data set as well. So we can actually just drop one of those out as well. And there we go, that's gone. And I'll just rename is holiday X to just is holiday. All right, and so now we have that renamed as well. Now we do need to perform some light, simple data cleaning on this, and I'm not going to go too into detail on this code, but just in the interest of time, I don't want the video to be too long, but if you have any questions on the cleaning steps I've performed or on the code, you can just let me know in the comments and I'll try to answer your questions. So here I'm just converting this date column to a date time column and keeping it in this format of day, month, year. And then here I'm just extracting the month and year from this date in case we need to group the data frame by month or year for any of our visualizations. This data set also contains, I think, like 20 stores, and each store has like 20 departments in it. It makes the data set pretty large. And just for the purposes of this video, I wanted to simplify that data set down a little bit. So for this demo, we're just gonna keep stores 1 through 5 and departments 1 through 5 for each of the stores. And we'll also drop duplicates because when we joined the data set, we did get some duplicates in there. And like I mentioned earlier, this data set also has data for 3 different years. And for the purpose of this video, we'll just limit the year to be for 2012. All right, so now let's start with our visualizations. And we're going to start with a simple line chart. And for this line chart, we're just going to visualize the sales by week for one store and one department in that store. So now first, let's filter down the data frame to the data that we want for this task. So we'll call it store 1 weekly sales. And for this, we'll filter it down to the data set where store is equal to 1 and the department is also equal to 1. So we're just visualizing the sales for that one department for that one store. And we'll take our Matplotlib library here, PLT, and the function to do a line chart is just plot. You will specify the X and Y that you want. So for X, we're going to use the date column. And for Y, we will use the weekly sales column. And when we run that, you will see we have a line chart generated. Now, I know you're probably thinking, this does not look good, and I would agree with you. It doesn't look great. We have the line, but there's no labels, there's no title. The dates are all like overlapping each other. You can't really read it. So next up, we're going to make sure that this looks a little bit better. So the first thing that we can do is we can actually set a size to this as well. So before we plot it, Matplotlib actually gives a figure function, and here you can set different attributes on the figure, but the main one we'll set here is the fig size. So fig size is width times height, and this is what we'll give it. We'll have it 10 by 5, then we'll plot it, which we're doing here. And next up, we will set the X labels, the Y labels, and the title so that anyone looking at this chart will know what this actually is for. Matplotlib actually has an X label, Y label, and title function, so that's what we're going to use to set these. So for X label, we want that to be the week, and we'll create a Y label, which is sales, and we'll put a $sign next to that so we know that it's in dollars. And we'll also create a title, and we'll call this chart weekly sales for store 1 for department 1. And each of these functions also takes a font size and font weight argument where we can set the size and whether or not we want the text to be bold or not. So we'll set, for the X and Y labels, we'll set the font size to 12 and we'll set the font weight to bold. I just think it looks better when these things are in bold, so I always put them as bold. We'll do the same thing here. And for title, we'll keep it mostly the same, but we'll make the font size 14. So now we can look at these changes and see if our chart looks a little bit better. So we'll call it plt.show. And if you're in a Jupyter notebook, you actually don't need to call this show function, but I like to do it because if you're running a script, you do need to call show. So I kind of just use it in notebooks too, just to keep it as best practice, but just a little tip there, you don't necessarily have to in a notebook. So here we go, we have our title and we have our X and Y labels. Now we can leave it like this, but we can make it look even a little bit better by formatting these dates a little bit more. Right now we just have it numerically here as like the year and the month, but we can actually have it as like the month name and then the day of the week that it was. So to do that, Matplotlib actually has a mdates library as well. So we can import that using matplotlib.dates as mdates. And we need to get the current axis of this figure. So to do that, we use the GCA function, get current axis, and we want to select the x-axis of this, and we'll set the major locator to show these things every 4 weeks. Right now it's showing every single month. We want it to show every 4 weeks. So we'll set this where mdates.weekday locator and set it to an interval of 4. So this will show a X tick every 4 weeks. And we also want to format that date. So instead of set major locator, we're going to use the set major formatter function, and we'll use the date formatter function, and we can specify the format. Do %b and %d. So here %b indicates to Matplotlib that we want to use the abbreviated month name, and then %d indicates that we want to use the day of the month. So for like January 17th, it would show Jan 17. And one last change we'll make is we'll also add some like light grid lines in here just to make this chart a little bit more readable. And for that, we use the grid function. We want to set visible equal to true. We can set a line style on here. And for this, I'll give it a dashed line. And we can set its like transparency. This takes values, I believe, up to 1, and I'll set it to like 0.4 so that you just kind of get a light dashed grid in the back. And when we run this, we see we have that grid in the back, and we have our new formatted dates down here. I think this looks a lot better than just having a x-axis tick at the beginning of every month, and it's a little bit more specific that the sales were around 15,000 on January 17th instead of just sometime in January. So now that we know how to make a singular line chart using Matplotlib, let's see if we can extend that to do a multi-line chart. That means on this chart, we're going to have more than one line representing different things. So for our use case, we want to recreate this chart. However, instead of just the line for the sales for store 1, department 1, we want the sales for department 1 across all 5 stores. So to do that, first we need to get a list of the unique stores that we have in our data set, which we know is the numbers 1 through 5. So we'll run the pandas unique function on our dedupe data set. And if we look at store list, you'll see that we have the list of 1 through 5. So now let's set our figure size like we did before. And we're going to plot the line the same exact way. Like we're just going to do plb.plot, and then we're going to give it our x and y. However, every time we call plot, that's how the line gets generated. So if we wanted 5 lines, we'd have to specify it 5 different times like this, and then specify the x and y in each one. So instead of that, what we can actually do is we can do a for loop. So we can do for store in store list. So for each of those 5 stores, we'll run that plot function. And our x here is the filtered data frame where the store is equal to whatever store iteration we are in the for loop. And then our department is still going to be equal to 1. And we want to take the date column of that filtered data frame. And we'll take the same thing for y. We'll just change date to weekly sales. Now, when we do multi-line charts, we're going to want to create like a legend here that shows which line corresponds with which store. So to do that, we actually need to create a label for this plot. So we'll define a variable called line label, and that'll be equal to store plus the string of the store that we're on. So for store 1, it'll say store 1. For store 2, it'll say store 2. And in this plot function, there is a label function where we'll just pass that, or a label parameter, for which we'll just pass line label. So when we run this, you see that we get all of these 5 different lines. But like before, you can see the title isn't there, the axis isn't set, and we don't have a legend either. So we'll go through and we'll add in the details of the chart, like the labels, the title, the axis, and the grids. And here you can see that you can do this outside of the for loop. You don't need to set it each time you run plot. You just set it at the end once your chart is already created. And in addition to this, we'll also add plt.legend. That'll actually show which line corresponds to which store. And we'll do our plt.show. And here you can now see we have a legend that corresponds to each line. So that's how you would do a multi-line line chart. Next, let's look at how we can create a bar chart in Matplotlib. So we're going to create a bar chart that shows the yearly sales for each of the 5 stores across all of their departments. The first thing we need to do is group our data set by the store and calculate a sum of all the weekly sales for the year 2012. So we'll take our dedupe data set and we'll run a group by store. we'll select the weekly sales column and we'll do a sum on that. And then we'll also reset the index because right now our index is going to be store and we want a data frame with the column store and weekly sales, not where the index is stores. So we can take a quick look at this. And we see we have all the stores and their total sales. And this is a sum of their weekly sales for the entire year. So let's specify our figure and figure size. And now we'll actually specify the bar plot. So for this, the function is aptly named as bar. That'll create the bar chart. And we will pass it store for the X value and weekly sales for the Y value. And before showing the chart, I'll also add in all the details of the X label, Y label, title, grid lines, and all of that. And I just will change this title as yearly sales for stores 1 through 5. I'll call it total yearly sales so that we know it's not by any department. So there we go. We have our bar chart. You can also change the color of the bars. You can set it to colors like red, blue, whatever you want, or you can even specify a hex value here. So we can give it this random hex value and you'll see you'll have green bars instead. So that's it for a bar chart. Pretty straightforward. Just change that plot to bar and you have a bar chart. Now let's take a look at scatter plots. And for this scatter plot, we want to track the weekly sales by temperature. So our x-axis is going to be temperature and our y-axis is going to be sales. For all stores across all departments, we want to see if there's like a relationship between those two variables. So let's start by setting our figure size to a width of 10 and a height of 5 again. And to do a scatter plot, Matplotlib just provides this scatter function. And here we will specify that we want temperature to be the X value. And just like before, we want weekly sales to be the Y value. And again, we'll make the chart look nicer. Instead, here we're just changing the title, the weekly sales by temperature, and the X label, the temperature. And when we show that, we see we have our scatter plot. So again, really straightforward. We just need to use scatter instead of bar or plot for this one. And the final visualization I'll cover today is a box plot. And for this box plot, we want to see if there is a difference in the spread of weekly sales depending on if a week is a holiday or it's not a holiday. So we're going to take our dedupe dataset and we'll use BoxPlot for this. Now here you can see that I'm actually running this directly on the data frame instead of using plt.boxplot. And that's because for this one, I'm grouping by a specific variable. And so here we'll specify column, which is the values that we want to plot. So that's the weekly sales. And then there's also this by parameter, and this will specify what we want to group our data frame by before we plot it. So we want to group it by is holiday. And what this will do is it'll give us a different box plot for each value of is holiday. So you'll see that this chart will actually have two box plots, one that shows the spread of weekly sales when is holiday is set to false, and one that shows the spread of weekly sales when is holiday is set to true. And also just specify our X label, Y label, and titles here. And when I run this, you see that we get our box plot, one for where holiday is holiday is false, and one for where is holiday is true. So you can see there's a lot more outliers in the sales when is holidays equal to false than when is holidays equal to true. Now on this chart, you might notice that you see this box plot grouped by is holiday. This comes up by default when you use the box plot like this. It's just telling you what the box plot is grouped by, and we don't actually want that title there. We just want the title that we've given it. So that's actually called a super title, and we can set that attribute on the on the Matplotlib object using subtitle. We'll just set that to an empty string. And you can see that that actually removed that title and just kept the title that we want. Now, as promised at the end of the video, I was going to go over some bonus tips. So the first bonus tip I have is that you can actually add text within the graph called annotations. So I've come back up to our first line chart here. And one way that you generally see these annotations used is that there'll be like text where there are certain spikes indicating why a spike has happened. So that's what we'll do here. And I want to add text over here that indicates that this might be a holiday spike. So right before we show our chart, we can run a function called annotate. And annotate will take a text string that we want to show. So we're going to call ours holiday spike. And I'll take an XY position of which point goes with that text. So for us, we wanted to find what values this point is at. And you can go through your data frame and you can filter it down to where the date is, between February 14th and March 13th, 2012, to find which one corresponds to this point. So you'd have to look for where weekly sales is, around maybe 60,000. I already did that before, so I know that XY is equal to February 17th, 2012, and that our Y value is equal to 54,060.10. Now this won't actually work because our x-axis is a date type column and we're specifying a string type column. So we actually want this to be a date. So we can do pd.toDateTime. So now this will be treated as the date of February 17th, 2012 instead of just the string. And we can also give it an XY text position. So right now the text will show up like right where this point is, and we want it off a little bit so that it kind of shows up over here. So to do that, we can specify that we want it at the same X value. We want it still around this area. We just want it off. We want it up here a little bit, so a little bit higher than what the Y value is. So we'll take our Y value and we'll just add like 3,000 to it. So I guess I could specify this as 5,700 as well. Let's take our actual date there. And we can also specify an arrow so that it'll point to the point. So that is just arrow props, and it takes a dictionary. And here we can specify the arrow style, which should be like a dash and then this greater than symbol. And we'll specify a color for the arrow as well, which we'll set to black. So now when we run this, you see you have a nice little annotation here that shows that this is a holiday spike, and you can add any text you want, you can add any color arrow you want. Pretty simple to do and adds a little bit more meaning to your chart as well. I have two more quick tips as well. So one of them is that you can set the style of this chart to be a certain default style. So there's styles like ggplot, 538, things like that, and all your charts will have a specific type of styling on them by default. So to get that, you'll set plt.style.use equal to whatever default style there is. So I like the 538 style. So we'll specify it to 538. And there's other values you can add as well that you could probably just Google plt.style and you'll get a list of them. So I run this. When I go back up here and run the chart again, you'll see we have kind of a different style than we had before. This is the 538 style of Matplotlib. And the last tip is that you can also save this figure if you wanted. So you can use the save fig function. But to do that, we actually need to save this figure object to a variable. So back in this line chart, we'll just set fig equal to this figure, rerun this. And then after that, we can do fig.savefig, specify the file name, so we'll just call it linechart.png, and we'll run this, and we can see in our file folder that we now have a linechart.png, and that is our line chart saved over here. So you might have saw in that previous clip that the sales and week were cut off from this image. So if that happens to you, what you can do is you can set this bbox inches equal to tight so that savefig knows, so Matplotlib knows how to adjust the plot margins to accommodate all the elements. So if you add this parameter to your savefig, then you'll get the chart where nothing is cut off. All right, so that is it for this video. These are the simple charts that I like to use in Matplotlib. Now this is part one of a two-part series. In the second part, I am going to show how to use Matplotlib to create more advanced charts like stacked bar charts and subplots. So if you're interested in that, make sure you subscribe to tune in for that next video. If you liked this one and it was helpful to you, I would really appreciate it if you liked the video and subscribed to the channel. And if you have any questions, please let me know in the comments below. Thank you so much for watching this video, and I will see you in the next one.